Hello, I'm Caroline Walker, and I'm speaking today about operational analytics and the Forecourt. Little bit of background information about me before we jump in. I'm with the company Warren Rogers. We provide compliance monitoring and also fuel systems diagnostics to retail petroleum operators, including several Sigma members. And one of the things I really find most exciting about my job is what I get to talk about today. And that is creating and mining these very rich data sets of information harvested from the forecourt. So let's jump in. Little overview of where we're headed in this talk. Any data analytics endeavor is only going to be as good as the quality of the data collection and data curation effort that underlies it. So we'll spend some time looking at important things you want to take into consideration as you lay the framework for everything that will rest on it. But I'm actually going to come back to that at the end of the talk because I want to jump in by addressing the big question, why? Why collect this data in the first place? What can we do with it? And when we think about what can be done with this rich data stream coming off the forecourt, there's so many things. I could easily fill a 5-hour talk, but probably nobody wants to hear me talk for 5 hours. So we're going to focus in on one area of application, and that is how this data can be used to help you optimize your field maintenance activities. So specifically, we're going to look at how this data can be used to reduce service costs, enhance your customer's experience, maximize fuel sales, and minimize loss. And a theme that we'll see throughout as we look at examples of all those things is how data like this can be used to move what might be a more traditional maintenance program to a program that incorporates more predictive and directed maintenance. All right, so there are some assessments related to flow rates, but there's no limits to what you can analyze once you have this data, right? You can know the sales impact of any of your maintenance activities. And here's an example report that we use to see how sales have changed in response to a maintenance event. So at this specific site, you can see that the before and after sales numbers led to over 1,000-gallon increase in sales, which represents about a 6% increase in sales for the site. And it's fun, once you have this data, you can also drill down further and see how that sales pattern played out across the meters. So right in the center of that plot, dispenser 18, that was the one that was having the issue, right? The blue bar shows sales before maintenance, much lower than sales after. But what's also fun to look at is how the other dispensers at the site compensated for dispenser 18 when it was struggling, right? You can see 19 picked up a little bit, 22 and 23 picked up some too, but an important takeaway is that the amount those others compensated with didn't make up for all that was lost from 18. All right, so we talked a lot about analytics. Now let's talk about the data that underlies it. What do you need to do to build a data stream of actionable forecourt information? Well, there's two places that are key that you want to pull data from. You want to exploit your ATG to get accurate product levels and water levels, and your dispenser meters to get accurate sales. And together, that's going to give you a data set of fuel movements and transfers. And you're going to aim for high frequency data collection, because that's going to give you a finer resolution into the things you'll be able to see in that data and the conclusions you can draw. And you want to create a data stream that you'll be able to use for real-time analysis. Once you've got that data coming in, what do you need to do with it before you can start reaching conclusions? Here's our data curation phase, right? If you're like most operators and you have multiple types of equipment at site, maybe multiple makes and models of ATGs or dispensers across your site population, then you're going to want to think about data standardization. You want to make all that data uniform so that you can do aggregate analyses across all of it, not just each site by itself. And the other benefit you will gain by doing that is that then those analytical tools you develop to sit on top of your data can be applied to all the sites. Second point here, I couldn't talk enough about this, right? But once you get your data, you're going to want to spend some time getting to know it. And your goal is going to be to discover the anomalies in that data, because there will be many. and you want to learn those anomalies and develop tools for cleaning them or flagging them, because you don't want to let spurious data trickle into your analyses and corrupt your conclusions. You have to be very vigilant about data flagging and data cleaning. So I put 3 bullet points up here just to get the wheels turning, things you want to be on the lookout for, but there will be many more, right? So site maintenance events, if you have a probe pull, that's going to give you erratic tank readings. You need to clean those out or flag them. Any run out or overfill events where you may not be able to get as accurate a reading from the probe, you want to watch out for them. And disrupted communications, you need to flag those because you do not want to confuse a time where your site was not selling fuel with the time where your site was selling fuel, but communications were out and you couldn't see it. Once you've done those things, you'll be in a great position to analyze the data and to start saving off archives to maintain the value of your data over an extended period of time. That will enable those longitudinal analyses that are very beneficial. One more thing you might want to think about doing with this data, right? We talked about the tank data, the dispenser data. Each of those things by themselves is quite informative and there are insights to be gained. But you really gain deep insights when you marry those 2 data sets together and now think about modeling your fuel system as a whole, right? Rather than analyzing tanks separately and meters separately, you want to analyze your fuel system. In order to do that, you're going to need to develop and maintain some metadata to incorporate in your modeling. And I've put together here some bullet points to keep in mind as you do that. You're going to need to develop proper meter to tank mappings, which dispensers are pulling from which tanks. If any of those dispensers are blending dispensers, you want to have in your metadata the proper blend ratios for the dispensers. If your tanks are manifolded, you want to incorporate that in your metadata so you can account for product flowing back and forth between the tanks. You certainly want to be doing continual temperature compensation to get accurate net product readings, product volumes. It's not a big deal. I mean, there's already temperature readings you can harvest from your ATG, but you need to utilize them. And finally, once you have done all that, you're probably in the most exciting position of all. You'll be ready to start building these custom charts for your tanks and manifolded tank systems that are going to give you the accurate and correct inches to volume conversion for your tanks as they are in the ground. Not some theoretical tank, built to factory specs, but your tank as it sits in the ground, as it's positioned. And what that will do for you is it will remove volumes of noise from your data so that you'll be able to get those deeper insights from your data stream.